Welcome back, grade 12s. Let's continue with our review. And now we're on question 7, which is calculus. Okay. Right. So this section is easy if you understand the rules of the game. So here we should bag all the 13 marks presented to us. Okay. So now 7.1 here says, determine the first derivative from first principle if f of x is equal to negative 4x squared, right? Okay, so let's quickly do that, right? So we want to find out what will the derivative be if we use the first principle. Now, every time they want us to use the first principle, you know that we have a formula that helps us find the first derivative, isn't it? Which is first derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So this is the formula that we're going to use anytime they indicate to us that we should find the derivative using the first principle. And now we can always use the rules that we learn, like the power rule or the sum rule, to find out what would the derivative be, just quickly, so that we verify our answer right here. Because we are going to have some manipulations and some calculations that are going to be involved here, right? Whenever we are simplifying f of x plus h minus f of x. But we just want to be sure that we are on the right track with our answer by quickly finding the first derivative using, in this case, the power rule. So you know that I'm going to multiply by 2, which is going to be negative 2 times 4, and right there at the top is going to be 2 minus 1. So this must be minus 8x. So it means that after deriving this using the first principle, what we should end up with is negative 8x. Okay, so let us go on here. Now, please take care or take note here. Remember that it says f of x is equals to the limit, isn't it? So we need to see the limit as h approaches 0. This part is important. Please do not drop it, okay? And this part comes after the equal sign. So in most cases, what you want to do is you want to keep the syntax that you have been given, okay? So let us continue like that. So we have limit as h approaches 0. And now in f of x, we're going to replace with x plus h, right? So this is going to be, let me just have a line here, a division line. We're going to have negative 4 into, and right here, we're going to replace with x plus h all squared like that. And we had negative from the formula. And now we subtracting f of x, which was also negative 4x squared like that. And this is still over h. Okay. So what are we going to have here? We're going to have the limit as h approaches 0. Then right here, we can expand this guy, isn't it? We can expand that guy. So that would be x times x giving us x squared, x times h, that would be xh. And we repeat the same thing, x times h again. So it means that we're going to end up with 2xh. Then we multiply h with h, we end up with plus or positive h squared. And right here, negative times negative, this gives us a positive x squared. So another tip here that I can give you is that anytime you are simplifying this, any term that does not have an h initially, after simplifying this guy here, must disappear, okay? So if those terms don't disappear, then you have to check the signs. The signs, you might have made a mistake with the signs. Like in this case, if I have negative here and I just written the negative 4x squared, then thinking that this negative also belongs to this 4x squared here, I just written one negative, then here I would have a negative and here I would also have a negative. But then if the terms do not have h, we know that they should disappear, isn't it? So now in this case, we should see that happening. So we have limit as h approaches 0 here. And now I can multiply into the bracket with this negative 4 that's outside. So we're going to have, let me have my division line here. So we're going to have negative 4x squared, negative 8xh, and negative 4h squared, and positive 4x squared like that. And now, as you and I have spoken about this, the terms that do not have h disappear. Negative, positive, it goes. Okay, then we continue on. What do we have here? We still have the limit as h approaches 0. Okay, so now we see that we want to now cancel out h from the denominator, all right? We want to cancel out h from the denominator. So it means that we are going to factorize h from the numerator up there. So we're going to have h into negative 8x, and we're going to be left with negative 4h like that. Close, divide. So now you see that the h in the numerator must always, there's an h in the numerator that must always cancel out an h in the denominator. Okay, in most cases, you'll see that that should happen, right? So now what are we left with here? We're left with the limit as h approaches 0 of the function negative 8x minus 4h. Okay, and now we can say, well, as h approaches 0, what should happen? So as h approaches 0, what we're going to have is negative 8x minus 4 into 0 like that. So we've substituted the value of 0, and we are left with what? Negative 8x, which is confirmed by our answer up here. So you and I are happy about this. So we know that we haven't made any mistake, and we're going to bag his marks. Okay. So let us go on to the second one. 7.2, they're saying determine f of x prime, which is the first derivative, if given that f of x is there, right? So we're given that f of x is equals to 2x cubed minus 3x. Okay, so we have 7.2 here, 7.2.1. So we're given that f of x is equal to 2x cubed minus 3x. I believe so. I believe that is what we have here. And it means that the derivative, or the first derivative, I'm going to use the power rule in this case. So 3 multiplied by 2, that's going to give us 6. And now I'm going to say 3 minus 1, that's going to give us 2 like that, okay? And here I'm going to have 1 multiplied by negative 3. That still is negative 3. And now I have 1 minus 1. So we're going to have x to the power 0, which will turn into a 1. 1 multiplied this negative 3. It means that our final answer for the first derivative is that guy there. Okay, so let us go on to 7.2.2. So what are they saying here? They're saying determine the derivative of 7. I think this is x. Yes, x squared cube rooted, right? And we have plus 2 negative 5 like that. Okay. So we know that whenever we have a radical or square root or cube root of some sort, we can change this into a fractional exponent. So let's do that. So this can be written as 7 times, we're going to have 2 at the top divided by 3 like that, right? Plus 2x minus 5. Okay, so it means that we're looking for the derivative of what's inside here. So the derivative of that guy, when we derive this guy, what are we going to have here? Maybe even if I do not write that, then I just now have my equal sign down here. I'm taking the derivative of this function. So what am I going to have? I'm going to have my 7 multiplied by 2 over 3 multiplied by x. And up here, I'm going to have my 2 over 3 minus 1, right? And in this case, this is going to be negative, because I'm going to have negative 5 multiplied by 2. That's going to give us negative 10. So this is going to be negative 10. And now I'm going to have negative 5, negative 1, which would give us negative 6. But then let's just stretch it out a moment. So what are we going to have here? 2 times 7, that's going to be 14 over 3. Now, up here, you have 2 over 3 minus. So this is going to give us negative 1 over 3 like that. Minus 10 to the power negative 6. So we can quickly take this guy underneath here. So we're going to have 14 over 3 multiplied by, I think this is supposed to be a 3 instead of a 2, yes. And minus, we're going to have minus 10 over x to the power 6 like that. And that would be our final answer like that, okay? So it looks like I've run out of space. So I'm just going to use this portion on the side here, okay? Just going to use portion on the side. So let's just check the question quickly. They're saying that for 7.3, for which values of x will the tangent to this function have a positive gradient? Will have a positive gradient. So now they're asking where would you place the tangent such that when it attaches to this function, it will have positive gradient. So they're asking us basically, where is this function an increasing function? Basically, that's what they're asking. Where is this function an increasing function? Okay. So we're going to find out from the first derivative, right? We're going to ask the first derivative, where is the function positive and where is the function negative like that. So allow me to have my 7.3 like that here. So here we are given that f of x is equals to negative 2x cubed, negative 2x cubed plus 8x like that, right? So now I'm going to use the first derivative, find the first derivative of this guy, because if we evaluate where is this function positive and where is this function negative, here I'm referring to the first derivative, then we could tell when will it become positive, when will it become negative, isn't it? Because we would have the x values where it changes sign, right? So we're going to have negative 6x squared here, and we're going to have a positive 8 like that, right? So now, remember that this function probably will look something like this. This function might probably look something like this, right? And this is what? The first derivative. Here, this is the sketch of the first derivative. Okay, so we're going to have some value x1 here, and we're also going to have some value x2. Okay, so where this function is negative, we know that those parts, these parts here, are linked with where the function is decreasing, isn't it? Where the function is decreasing. And you see that the top part here, this part here, up here, which is positive here. That's the part where the function is increasing. This is the part where the function is increasing. Meaning that I should attach, if I attach my tangent and between these x values here, x1 and x2, if I attach my function or my tangent between x1 and x2, then I would have attached it where the function is an increasing function, and therefore that tangent will have positive gradient like that. So now it means that our job is to find x1 and x2 and report this interval, that the values of x for which this information is going to be true must be between x1 and x2. So for us to get this x1 and x2, it means that we must equate our function to 0 like that. Okay, so 0 is equals to negative 6x squared plus 8. Take 8 to the other side, or you can take this 6x squared equals to 8, divide both sides by 6. And you get that the value of x squared is going to be 8 over 6 like that. So it means that the value of x is going to be plus minus 8 over 6. So it means that one of the values here, let's have it like this, one of the numbers here is going to be associated with the negative, isn't it? So it's going to be negative 8 over 6. And this value here is going to be associated with positive 8 over 6 like that. So it means that the value of x that we're looking for that will satisfy the question there, it means that we are going to report our answer as x, therefore x must be between this value here, 8 over 6, and it must be between this value here, 8 over 6, where this guy is going to be negative like that. Okay. Hopefully that has made sense to you guys, and I will see you on the next one. Cheers.